All right, so in our last lesson, we talked about Pascal's triangle, and we introduced his triangle that he created all the way up through row 8. And you could continue this all the way for an infinite number of rows, but we're going to stop at row 8. Now, we learned what it was, but we haven't learned how to use it, what it's for, and why we've learned this. So we're going to explore that a little bit further in today's lesson when talking about the binomial theorem. Okay, so one of the first things that I want you to take a look at is in Pascal's triangle, recognize that we start with row 0, okay? Row 0 all the way at the top. And row 0 is just the 1. So whatever row you have, you're going to have one more term. So like row 0 has one term. Row 1 has 2 terms. Row 2 has 3 terms, and so on, okay? So whatever row you're in always has one more term than the previous row as well. Okay, so when we're looking at Pascal's triangle, I had asked last week if you saw any patterns and to look through it. And I know we haven't talked how to actually use it yet, but we're going to expand on that right now. All right, so if you were to look at number 2, okay, number 2 says x plus 2 to the 4th power. All right, so get this. If I were to multiply out, last week I had you manually write out x plus 2 times x plus 2 times x plus 2, right? And we multiplied out. It just took a while, right? It just took a while. And we know that by doing that, we can get the answer, but Pascal's triangle is used for a shortcut. So I don't need to multiply it out like that. What I can do is, since we're using something called the binomial theorem, we know what a binomial is. Okay, a binomial has 2 terms. You can't combine these 2 terms, and it's raised to the 4th power. A shortcut is this. You find first the row that corresponds with the degree that it's raised to. So x plus 2 to the 4th, we're going to look at the 4th row. All right, so if I look at the 4th row, the 4th row is right here. Okay, there's always one more term, so there's 5 terms in the 4th row, but we match up. All right, so we got a 4 here, we got a 4 here. Awesome. I'm going to write out what I see in the 4th row. All right, I see a 1, I see a 4, I see a 6, I see a 4, and I see a 1. Okay, and what I'm going to do here is, let me move this in a little bit. What I'm going to do here is, I'm going to take this term and this term, and think of it as this. I'm going to think of the first term as A, and I'm going to think of the second term as B. All right? And that's just to identify each term. Now, if I were to write A, and then also write B, what I want you to do is this. I want you to take whatever the first term is, A, and raise it to whatever power. So this is to the 4th power here. We're going to raise A to the 4th power. We're going to then raise A to the 3rd power. 4, 3, 2, 1, 0. And then, now that we're at B here, all the way in the end, we're going to raise B to the 4th power. 4, 3, 2, 1, and 0. Okay, so what I did was I took A and raised it to the 4th power. That's the power that we're starting with. And then went down 1. I went down 3, 2, 1, 0. And then it's the exact opposite for b, where b really starts at 0 right here. Starts at 0 and goes 0, 1, 2, 3, 4. Or you can look at it backwards and go 4, 3, 2, 1, 0. Okay? So now that we've written that, if we know that if we know x right here, x is a, and then 2 is b, I'm going to go ahead and add all this up, and I'm going to replace, every time I see a, I'm going to write x, and every time I see b, I'm going to write 2. All right, so I'll say 1 times x to the 4th, and then multiply that by 2 to the 0 power. And I'll go ahead and just put that in parentheses as well. Plus 4 times x to the 3rd times 2 to the 1st. Plus 6 times x to the 2nd power times 2 squared. Plus 4 times x to the 1st power, and then times 2 to the 3rd power, plus 1 times x to the 0 power times 2 to the 4th power. All right, and I know that's all jumbled up, but we're going to rewrite it here in a second. Let's look at this first term. All right, and if we were to multiply all this together, right, first we'd use PEMDAS, right? What's inside the parentheses? Can't do anything inside the parentheses, that's just multiplication, okay? So we're going to move the exponents, okay? 1 times x to the 4th, and then I have 2 to the 0 power. 2 to the 0 power, anything to the 0 power is not 0. Anything to the 0 power is 1, okay? So I could write this as 1 times x. Oops, I'll write it like this. I'll say 1 times x to the 4th power. 2 times 0 is 1, so times 1. And that's what you get, all right? And then we haven't simplified that further. We'll leave it there. Then I have 4 times x to the 3rd power. And then times 2 to the 1st power. 2 to the 1st power is 2. Okay, so now we've completed this term right here. Now let's look at this one. Okay, 6 times x to the 2nd power is 6x squared times 2 to the 2nd power is 4. Okay, and then I get 4 times x to the 1st power. X to the 1st is x times 2 to the 3rd power. 2 times 2 is 4 times 2 is 8. Plus, remember, 1 times x to the 0 power is 1. And 2 to the 4th power is 16. 2 times 2 is 4. 8 times 2. Sorry, 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. Okay. Now we're going to simplify even further. 1 times x to the 4th times 1 is really just x to the 4th. Right? And then 4x to the 3rd times 2. Well, 4 times 2 is 8. So I get 8x to the 3rd. 6x squared times 4. 6 times 4 is 24. All right. And then I have 4x times 8. And that gives me 4 times 8 is 32. And then 1 times 1 times 16 is 16. And I have now expanded my binomial by using Pascal's triangle. So let me just back up here. Okay, our first step, this was our original problem right here, right? We took a look at our original problem and we saw that we had x plus 2 to the 4th power. Now, since it's raised to the 4th power, we're going to look at row 4. Okay? And we take whatever is in row 4, which was 1, 4, 6, 4, and 1, and we rewrote it. We wrote it right here, 1, 4, 6, 4, 1. Once you rewrite it, we are then replacing whatever's for A, right? We're going to put an X there. So we write our A's, we write our B's, A, B, A, B, A, B, A, B, all the way across. And then whatever power we're raised to, X plus 2 to the 4th power, that's what power you're going to start with for A. A will be raised to that power. So 4, and you move down, 3, 2, 1, 0, until you end at 0. You will always end at 0, all right? 4, 3, 2, 1, 0. And then you're moving the other way, 4, 3, 2, 1, 0, 4, 3, 2, 1, 0. Moving that way, or you can move down 0, 1, 2, 3, 4. Okay? And once you've done that, you then just solve. You substitute in A for X, or sorry, you substitute X for A and 2 for B. You substitute in those values, and you move through and then simplify each term. And at the end, you get X to the 4th plus 8X to the 3rd plus 24X squared plus 32X plus 16. Okay? So now, even though that may have seemed like a lot, I spend most of that time explaining it. It's actually a lot quicker this way than going through and multiplying it X plus 2 times X plus 2 plus X plus 2, especially as you move on to bigger numbers, okay? So what I'm going to do is I'm going to leave Pascal's triangle up here, and I'm just going to keep rewriting this, okay? So that will be number 2, and I'm going to erase all this. All right, and we're going to move on to number 3. All right, and number 3 is, I'll write it up here. Number 3 is X plus 3 to the 3rd power. Okay? Like I said, that's the same as multiplying X plus 3 times X plus 3 times X plus 3. But we're going to use Pascal's triangle. Notice that it's raised to the 3rd power. Okay, that means we're going to look in row 3. What's in row 3? Well, I have a 1, 3, 3, 1 inside the triangle. So I'm just going to write out. I write out 1, 3, 3, 1. And then I'm going to write A, B plus A, B plus A, B plus A, B. That's my A. That's my B. And once I have that, I can substitute in those values. So I can say equals 1 times X. I'm sorry. Before I do that, I want to set my exponents. So, skipping steps here. I want to take that to the 3rd power, since it's raised to the 3rd power, and write A to the 3rd power. Okay. And then I can write A to the 2nd power, A to the 1st power, and A to the 0 power. Same thing for B. I'm going to start at 0 and just count up 0, 1, 2, 3. Okay. Now I'm substituting my value. So I have 1 times X to the 3rd times 3 to the 0, because 3 is B, plus 3 times X squared times 3 to the 1st, plus 3 times X to the 1st power times 3 squared, plus 1 times X to the 0 power times 3 to the 3rd. Okay? So moving on, if I'm looking at this and simplifying, I can say 1, X to the 3rd is X to the 3rd, 3 to the 0 power, anything to the 0 power is 1. Okay? All right, this is 3x squared times 3 to the 1st power is 3. Okay? And then if I'm looking at this, 3 times x to the first is just 3x. 3 squared, 3 times 3 is 9. Okay, continue to move across here. 1 times x to the 0 power is 1. Okay, so 1 times 1 is still 1. Okay, and then times 3 to the third power. 3 to the third power is 3 times 3 is 9, times 3 is 27. All right, now we'll simplify one last time. 1 times x to the third times 1 is just x to the third. Okay, 3 times 3 is 9, so it'd be 9x squared. Okay, and then 3 times 9 is 27. Whoops. 27x. And then I'm adding 27 on the end there. Okay, so I've expanded. This is my answer. Right, I guess I'll circle it in front of the equals there. X to the third plus 9x squared plus 27x plus 27. Okay, and this is how we would complete we would use the binomial theorem and use Pascal's triangle for these last two as well. I'm going to go ahead and erase this, and we can move on to the next problem. Okay, we're going to deal with some bigger terms here. All right, so this one is x plus 4 to the 5th power. All right, so I'm going to write it up here. I'll just say number 4 is x plus 4 to the 5th power. Okay, now that I have that, I'm going to look in row 5, because we're raised to the 5th power, whatever it's raised to. This is what's in row 5. So I'm going to take that and write it out. Right, I'm going to say 1, 5. I'll say 1, 5, 10, 10, 5. Kind of writing these too close. I might space it out a little bit more. 1, 5, 10, 10, 5, and 1. Okay? And once I've done that, actually I'll go ahead and erase this and I'll backtrack so that way I can get that out of the screen rather than having that circled the entire time for the rest of the problems. All right, so once again, 1, 5, 10, 10, 5, and 1. Okay, and I'm now going to add a b plus 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 a b. Okay, and since we started with the 5th power in the 5th row, we're going to start a with the 5th power. A to the 4th power, a to the 3rd, a to the 2nd, a to the 1st, a to the 0. And then we'll work up from 0, 0, 1, 2, 3, 4, 5. Okay, so it should always match. If you're starting with 0, you should be counting up to 5, and 5 counting down to 0. All right, so now that we're here, let's go ahead and identify that x is a and my b is 4. Okay, so I'm going to substitute in those values. So I'm going to say 1 times a is x to the 5th times 4 to the 0 plus 5 times x to the 4th times 4 to the 1st plus 10 times x to the 3rd times 4 squared plus 10 times x squared times 4 to the 3rd plus 5 times x to the 1st times 4 to the 4th plus 1 times x to the 0 times 4 to the 5th. Okay, and now that I've come here, I've got to simplify, right? We realize that 1 times x to the 5th is just x to the 5th. You're going to multiply that times 4 to the 0 power. 4 to the 0 power is just 1. Anything raised to the 0 power is 1. All right, then I get 5x to the 4th times 4. Okay, and then I'll get plus 10x to the 3rd. 4 times 4 is 16, plus 10x squared, and 4 to the 3rd power, let's see, 4 to the 3rd power, 64. Okay, plus 5 times x to the 1st, which is just x, times 4 to the 4th power, and 4 to the 4th power is 256. Big number. Okay, and then adding up the last row here, or the last term, we have 1 times x to the 0. Okay, x to the 0 power is 1, and then 4 to the 5th power is 1024. All right, so now let's take each term. X to the 5th times 1 is x to the 5th. Okay, 5 times 4 is 20, so 20x to the 4th. Okay, and then 10 times 16 is 160, plus 10 times 64 is 640. Can you imagine multiplying all this? It would have taken forever just writing this out. And then we'll say 5 times 256 is 1280x plus 1024. And that is how I would expand what originally started off as a simple x plus 4 to the 5th power. We were able to expand it all the way out to this, right? That's exponential growth. All right, that's number 4. All right, number 5, we're going to do a little differently. We're going to try and do it horizontal so I can put everything in here. And the problem for number 5 is x plus 5 to the 8th power. Okay, and according to Pascal's triangle, when we write this out, row 8 looks like this. 1, 8, 28, 56, 70, 56, 28, 8, and 1. Okay, this just gives us a little bit more room. All right, and then I'm going to write my A, B plus, 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 all the way down. Okay, and now that I'm here, I'm going to go ahead and identify that x is my A and 5 is my B. I'm also going to raise, since this is to the 8th power, I know that I have A to the 8th, A to the 7th, A to the 6th, A to the 5th, 4th, 3rd, 2nd, 1st, and 0 power. And then here I have B to the 0, B to the 1st, B to the 2nd, B to the 3rd, 4th, 5th, 6th, 7th, and 8th. Okay, and I'm going to substitute x for A and then 5 for B. So I'm going to rewrite this down here. I'll say 1 times x to the 8th times b, which is 5 to the 0, plus 8 times x to the 7th times b to the 1st, plus 28 times x to the 6th times b squared, 5 squared, plus 56 times x to the 7th, x to the 5th, times 5 to the 3rd power, plus 70 times x to the 4th power, times 5 to the 4th as well, plus 56 times x to the 3rd power times 5 to the 5th, plus 28 times x to the 2nd power times 5 to the 6th power, plus 8 times x to the 1st power times 5 to the 7th, plus 1 times x to the 0 power times 5 to the 8th power. This is a super long one, right? All this for one problem. We're going to start simplifying. 1 times x to the 8th is just x to the 8th. 5 times 5 to the 0 power is 1. Okay. Then I get 8x to the 7th times 5. I get 28x to the 6th. 5 times 5 is 25, plus 56 x to the 5th. 5 to the 3rd power is 125. All right, these are going to be some big numbers. Plus 70 times x to the 4th times 5 to the 4th power, which is 625. Plus 56 times x to the 3rd power times 5 to the 5th power, which is 3,125. Plus 28 times x squared times 5 to the 6th power. And I don't expect you to know these. You have to use your calculator, right? X squared, so that would be 5 to the 6th power is 15,625 plus 8x. 5 to the 7th power is 700. Oh my goodness. Let's see. If I can fit this in here. 78,125. Plus 1 times x to the 0 power is 1. So that would just be 1 times 5 to the 8th power, which is 300. Oh goodness. If I can squeeze this in here. 390,625. Right? That's a big number. Try and end the parentheses there. All right, so let's multiply out. Let's close this out. So I'm going to have x to the 8th plus 40x to the 7th plus 28 times 25 gives me 700. So 700x to the 6th plus 56 times 125 is 7,000. 7,000x to the 5th power plus 70 times 625 gives me 43750 x to the 4th plus 56 times 3125, which is 175,000 x to the third plus 28 times 15625, which gives me 437,500 x squared plus 8 times 78125, which gives me 625,000. And then the last number, 390,625. Okay, and that is my answer. And I'm not going to give you a problem like that on the test. But the whole purpose of that is for you to realize that if you were to multiply all that out using the box method, that would take forever. Instead, you can use Pascal's triangle. And even though it's not quick, it's a lot easier. And it's a shortcut that he had found out. Okay, and he had used, and we now call it Pascal's triangle. So with this, that was the end of our homework number 17, expanding binomials.